Graphing is an essential part of physics, being able to graph motion. We've got two basic types of graphs that we're going to be focusing on in this class. And so I prepared this to help explain how to interpret those graphs. So first step, whenever you're doing this, you always need to check what your labels are, so what your axes are. It tells you what variables you're dealing with. In this case, we have a displacement versus time graph. In a displacement versus time graph, the slope is equal to the velocity. So when you have to think about slope mathematically, like in algebra class, that's what we're talking about. The slope of this means velocity. So let's give some examples. If you have a steep slope, that means you have a fast speed. So there you go. That green one, that's nice fast. If you have a small slope, that means you have a very slow speed. So your purple, that's a slow speed. If there is no slope, that means the object is at rest, which means the velocity is equal to 0. The slope is 0, velocity is 0 because slope is the velocity. And that means at rest, right there in blue. Not moving, at rest, staying still, whatever you want to say, however you want to describe it. Okay? Also, this slope means velocity. We have both positive and negative slope. Okay? Positive slope means that you're moving in the positive direction. Positive direction just means moving to the right, moving up, moving forward, whatever relative motion that is. Then, a negative slope means that you're moving in a negative direction. Okay? So negative direction is exactly the opposite of positive direction. So if positive is right, negative is left. If positive is up, negative is down. If positive is forward, negative is backwards. Okay. So, slope equals the velocity in a displacement versus time graph. Velocity is both speed and direction. So as we said, speed, we're talking about how steep that slope is, either fast or slow. And the direction is either positive or negative. Okay? You're giving you your direction left, down, backwards if it's negative, right, up, or forward if it's positive. So let's do a few examples here of the motion and compare that to its graph. Okay, so slow to the right. The green car moving slow to the right, that's the green graph. Moving fast to the left, that's the purple car. Okay, and the red car is a rest, doesn't go anywhere. Now, what if the velocity is changing? It's not a constant velocity. All of these examples are constant velocities. Those linear straight line slopes, a straight line means it's constant. And because the slope is velocity, they're all constant velocities. A constant velocity of 0 at rest, a constant negative steep velocity fast to the left, a gradual constant velocity moving to the right. Okay? Now we have changing velocity. When the velocity is not constant, but it's changing. Every second, the velocity is faster, so we're talking about acceleration. It's going faster and faster and faster, so that means every second the slope is steeper. So, speeding up, accelerated, we end up with a graph that's curved. Okay? So right there, at rest, very slow, slow, fast, very fast. If you notice that slope is getting steeper and steeper and steeper, and you end up creating a curve. Deceleration is also a changing velocity. However, in this situation, every second it's going slower. So there's less slope. Okay, it's a less steep slope. So you have to start off with a fast velocity, a really steep slope. And remember, deceleration is also negative acceleration. So if you see it curved this way, then it has to have a negative acceleration to it. Okay, we end up with a curved graph. So very fast, then just fast, then slow, then very slow, and then at rest. So it curves the other direction. Alright, so let's see how much you learned. Give yourself a little test. Look at those descriptions and find the graph that matches. So, at rest. Which graph matches at rest? At rest, that's the blue graph right there. Horizontal linear graph. Fast to the left. fast and to the left, going to have a nice steep slope for the fast. Negative slope gives us the left motion, purple graph. Okay, slow and to the right. Slow means going to have just a little bit of slope to the right, positive, gradual slope. There you go. Accelerating means the slope is getting steeper and steeper and steeper, so it's going to curve. That's the orange graph. And decelerating, it's the last one there. The slope gets less and less and less every second. All right. Now we have a new type of graph. This is a velocity versus time graph. In a velocity versus time graph, you interpret it very differently than a displacement versus time graph. In this one, in a velocity versus time graph, the slope is equal to acceleration. So, if the slope is acceleration, what does that mean? Well, no slope means that you have a constant velocity. Okay? Linear means constant, so as long as it's a straight line, we have something that's constant. But if the slope is 0, that means it's a constant velocity. So, if you look at the numbers over here, on the y-axis, these are the velocities. Fast constant velocity, something high up. A slow constant velocity, something low down. And then at rest is a 0 constant velocity. Right there, the velocity is 0 constantly. Okay, so those are all linear, so they're a constant velocity because this is a velocity versus time graph. Horizontal means a constant velocity. Now if you have a steep slope, that means you have a fast acceleration. So we have like a Ferrari that's drag racing, going as fast as it possibly can. So nice steep slope, it speeds up very quickly. Okay? If you have a small slope, we have a slow acceleration. It is speeding up, it's just doing so very slowly, so like a smart car. Okay? Alright, so pay attention to always which type of graph it is. This is velocity versus time, so your slope is equal to acceleration. If you have a positive slope, we're going to have the acceleration. Okay, so fast acceleration, slow acceleration. What if you have a negative slope? That means it's decelerating. Okay? So a deceleration, a slow deceleration, this is like coasting to a stop. When you take your foot off the gas and you slowly slow down to a stop. A fast acceleration, fast deceleration is like slamming on the brakes. You decelerate and you do so very, very quickly. And that is interpretation of your different types, your velocity versus time and displacement versus time graphs.